Hello everybody. Today we are going to take a look at lesson 3-5, dealing with solving systems of equations in 3 variables. We will not be doing any graphing today. Today we are going to be using a lot of the substitution method and a lot of the elimination method. So this is definitely going to be a lot of algebra today. I just have a series of examples that I'm going to go through with you. But before I get to those, I just want to take a minute to go through what kind of solutions you can expect today, because they are going to look slightly different than a system of equations with just 2 variables. The first option for a type of solution is what we call an ordered triple. So before, when we were figuring out where these lines intersected, we were figuring out an ordered pair, so x and y. Well, an ordered triple is going to give us x, y, and z. All right? It is also possible to have no solution, and I'll show you an example of that. And then finally, it is possible infinitely, to have infinitely many solutions or infinite solutions. Okay, so I'm going to try and show you one of each. Oops, I spelled this wrong. Infinitely many solutions, to give you a good idea of what you can expect in today's assignment. So here is the first one. We are just going to solve the system. That's what the directions will say, just solve. So our first one looks like this. 5x plus 3y plus 2z equals 2. Then we have 2x plus y minus z equals 5, and then x plus 4y plus 2z equals 16. Now at any point throughout this video, if you need to pause, please just raise your hand and request that you pause the video, because I am going to go through this a little bit quickly just because I am limited for time as far as recording goes. Alright, so the first thing that you want to do when you have a system in 3 variables, you want to use elimination to eliminate one of the variables. So I'm looking at these and I'm thinking to myself, okay, well, I'm going to go ahead and I'm going to eliminate z. So in order to do that, I'm going to use the first one and the third one. Now you can pick any 2 equations and you can eliminate any variable. I'm just going to choose to eliminate z. So in order to make that happen, I think what I'm going to do is I'm going to multiply this bottom one by -1. So when that happens, I get negative x minus 4y minus 2z equals negative 16. Now I'm just going to rewrite this top one. I'm not multiplying it by anything. I'm just rewriting it. So 5x plus 3y plus 2z equals 2. So now using the elimination method, remember we always add with elimination, I get a 4x minus y, these are gone, that's what we wanted, equals negative 14. Okay, so that's the first step. Now the second thing I'm going to do is I'm going to use a different combination of 2 equations, and I'm going to eliminate z again. Alright, so to eliminate z again, and it doesn't matter what you choose, I'm just going to choose the first 2. Alright, so in order to do that, I'm going to multiply this through by 2. So if I write that down here, I get 4x plus 2y minus 2z equals 10. And now again, I'm not multiplying anything here, I'm just rewriting this. So 5x, 3y, 2z, and 2. All right, so now when we add, we get 9x plus 5y, z's are gone, that's what we wanted, equals 12. So now we have 2 equations that are that just have x and y in them. All right, so that's why we eliminated z twice. We have two different equations that have x and y in them. At this point, you can either use substitution or elimination, and you want to eliminate another variable. All right, based on my numbers here, I think I'm going to use substitution because I have this right here. So in order to do that, I get negative y equals negative 4x minus 14. So if I divide through by negative 1, I get y equals 4x plus 14. Okay? So now I'm going to take this and I'm going to plug it in here. And that will allow me to solve for x. Alrighty? So now, if I plug this in, I get 9x plus 5 times 4x plus 14 equals 12. And I went right into my arrow. Sorry about that. Distribute. 5 times 4x is 20x. And then 5 times 14 is 70. Combine like terms. So 29x plus 70 equals 12. Now if I subtract 70 over, I get 29x equals negative 58. Okay, now I'm going to divide that by 29, and I get x equals negative 2. All right, so just to sum it up, I eliminated twice. Actually 3 times. I eliminated the z up here, then I use a different combination of 2 equations to eliminate the z again. Then from there, I chose to use substitution, but remember, you can use elimination again if you want to. I just chose to use substitution and got it down to solve for one variable. All right, now I'm going to go back up. So I'm going to take this variable, and I'm going to go back up to here, plug her in. So y equals 4 times negative 2 plus 14. So that would be the same as negative 8 plus 14. So that means that y would be 6. Okay, so I got 2 of them. We just need 1 more. So now I'm going to take the x and the y, and I'm just going to plug them in one of these. It doesn't matter which one. How about the bottom one? So how about I plug them in this one right here? So when I do that, I get negative 2 plus 4 times 6 plus 2z equals 16. So this is negative 2 plus 24 plus 2z equals 16. So that would be the same as 22 plus 2z equals 16. If we subtract that 22 over, we end up with negative 6. So it looks like z is negative 3. All right, so it looks like we have an ordered triple. So our final answer is negative 2, 6, negative 3. All right, now again, feel free to pause and rewind if you need to. I know I went through that quickly, but I only have limited amount of time on this. All right, next one. Number 2. We are going to do 2x plus y minus 3z equals 5. Then we're going to go x plus 2y minus 4z equals 7. Then 6x plus 3y minus 9z equals 15. So again, the first step, decide which variable you want to eliminate, and then go ahead and pick 2 equations that you want to eliminate with. So maybe I'll eliminate x on this one. So I'm going to choose these first 2 equations here. So in order to do that, I'm going to multiply this one through by a negative 2. Okay, so negative 2x minus 4y, that turns into a plus 8z equals negative 14. Rewrite this one, 2x y, negative 3z equals 5. Turn it into a giant plus problem. X's are gone, that's what I wanted. So I get negative 3y, I get a positive 5z, and I get a negative 9. All right, now I want to eliminate x again. So in order to do that, I'll use the first and third. Again, it doesn't matter. So for this one, if I multiply through by negative 3, we get negative 6x plus negative 3y, or minus 3y, turns into a plus 9z equals negative 15. Rewrite this one. 6x plus 3y minus 9z equals 15. Turn it into a giant plus problem. Okay, x's cancel, that's what we want. Wait a minute, looks like y's are going to cancel. Looks like z's are going to cancel, so we get 0. Oh, those cancel too. We can't really move forward, can we? So when you get a solution that is a true statement, here is an example of infinite solutions. Okay. So a no solution problem would present itself much the same way, only remember that this would not be a true statement. It would be a false statement. It might say something like, I don't know, 5 equals 7 or something like that. Okay, my last example is going to be, it's going to look a little bit different, but I know you're going to have one like this on your test, so I just want to make sure that we go through one like this. So hopefully I don't run out of time. A plus B equals 3. Negative b plus c equals 3. A plus 2c equals 10. So this is still a system of 3 equations. There are still 3 variables here. Notice you have an a, b, and c. The difference is that not all 3 variables are in every equation. So in a situation like this, rather than starting with elimination, it would make more sense to start with substitution. And you can solve for any one of these variables. I'm just going to pick A. So like if I solve this first one for A, I get A equals 3 minus B. Excuse me. All right. So now I'm going to take this and I'm going to plug it in for that A. So I get 3 minus B plus 2C equals 10. Really, the only thing I can do to simplify is subtract that 3 over. So I have negative b plus 2c equals 7. Okay, now what you may notice is we have an equation with b and c, and we have an equation with b and c. Now we can use elimination if we want to. All right, notice both of these are negative b's, so we're probably going to multiply one of them through by a negative 1. I'll just pick this one. It doesn't matter. So now that means that I get b minus c equals negative 3. I'm just going to rewrite this one. So I get negative b plus 2c equals 7. B's are gone, so I get c equals 4. All right, now it's just a matter of substituting in to figure out these other 2 variables. So if I take this c and put it in this one right here, I get negative b plus 7 equals 3. So that means negative b equals negative 4. So b equals 4. Got it. Now I'm going to take it doesn't matter, we got to figure out, excuse me, we got to figure out A. So maybe I'll put that B into here. So now A plus 4 equals 3. So it looks like A is negative 1. Remember, when you don't have X's and Y's and Z's, just put them in alphabetical order in your ordered triple. So negative 1, 4, 4. There it is. Now again, if you need to rewind this at any point, please do. For your assignment today, you are going to be on page 150 to 152, numbers 9 through 17, the odds. It's not too many, I know.